Morning, everyone. How's everyone doing? I hope you're doing well. Today we are just going to do like a normal short class. But let's first start with a do now like we normally do. Write a sentence describing my mistakes, then fix them. If you don't have a pencil or paper with you, you're going to want to get that right now so that you can do these problems. Remember, writing things down is going to be best for you instead of trying to remember them. So if we're going to graph the polynomial, we know that it says f of x equals negative 1 over 30, x minus 5 squared, x plus 3 times x minus 1. And the first thing when looking at this problem, first look at where you have your end behavior, look at where those zeros are, and then right now, write a sentence describing mistakes, and then fix them. So if you need to pause it right now, pause the video, and then you can work on the problem. All right, so we're back. You've done the problem. First thing I'm going to look at is the end behavior. We want to determine, is this function going up as x gets larger or is it going down? So as x gets larger, is the graph going up or down? And remember what tells us that? You're right, the a value tells us that. So the a value is negative, so our graph shouldn't be going up as x gets larger. Our graph should actually be going down. So next thing we want to look at is what is n? So how do we determine n? That's right, we count the exponents. So I can see that we have a 2, we have a 1 and a 1. So then we know that n equals 4. And with an even function, is our graph, or even degree, is our graph going to be, are they going to be the same? So imagine me with my arms both up in the air, or are they going to be different where one arm is up and one arm is down? You're right, it's going to be the same, so because it's even. This one is the same, but we can see that since our graph is going down, that we know that our other side also needs to go down. All right, so let's plot our zeros. So we have x minus 5, we have x plus 3, and x minus 1. So x minus 5 means that our graph is going to have a 0 at positive 5. So positive 5, notice that's the same spot that this one had. We can also see that we have a 0 at negative 3. So negative 3 for that plus 3. And then we also have one at negative 1 or at positive 1 where it's x minus 1. But when we look back at this, we can see that x minus 5 squared, that means that we have this x minus 5 squared, we know that we have a 0 at positive 5, and it has to be a max or a min. So this has to be a max or a min. We know that the other two we're just going to go straight through. So if we start at the left-hand side, we know we have to go through that one. So my arrow is not going to be over here where I had it. I'm probably going to want to change it to down here. I need to go up through, go down through the other one. And then it looks like this is going to be a maximum. So let's look back to the prompt. It says that we need to write a sentence describing the mistakes and then fix them. So the mistake was really the end behavior and one of the zeros. So we could say, as x gets larger, the function will go down. And then we can also say that we know that at positive 5, we should have a max or a min. At the 0, 5, the graph needs to have a max or min. Spelling is still difficult with nobody here. So at the 0, 5, the graph needs to have a max or a min. So then we fixed the mistake already. We did that first, and then we went back and described the mistakes. Maybe it's easier to do it that way. Maybe you found the mistakes and then you did it the other way. So let's see what we're going to be doing for the rest of the class today. We're going to be looking at 6 problems. It's actually going to be 5 problems. I just realized now that we will not have 6 problems. I'm just going to go through 5 problems. We're going to correct the homework. You'll have time for that. And then also, so that's practice 5. And then your homework assignment will be to 5.1 practice 6. Questions 3 through 10. We'll get to that. Also notice that we're going to try to do a quiz on Thursday. So we're going to keep this thing happening on Thursday. And our objective today, we're going to be looking at learning remotely. And then, and that's just like to see how this works, please give me feedback. You can make sure to smash the subscribe right here. It should be about there on your screen. And then review graphing and analyzing polynomial functions so we can demonstrate the standard. All right, so let's keep moving on here. So graph the function. This is really similar to what we just did. We're going to, first we want to look at what is our a value. So our a value is negative. So a is negative. And a negative a value means that as x gets larger, the graph is going to go, that's right, the graph is going to go down. So we're going to draw an end behavior of going down on the right side. Next, we want to figure out what is the degree of the function. So what does n equal? That's right, n equals 5. And 5 tells us that our graph, is the graph the same or is it different? Meaning the 2 endpoints. So imagine my arms both being up in the air. So is it going to be a graph where it's like this? Or is it going to be a graph that goes like this? So is it going to be like this? Or is it going to be, oh, you can't see me circle something. Is it going to be like this or like this? So if it's odd, we know it's going to be opposite. You're right. So opposite, we're going to know that it's going to be going up. And then we can plot our zeros. X plus 3, that means that the function, or the 0 is at a negative 3. At x minus 1, we know that the graph is going to be at positive 1. So we can plot our zeros. And now we need to figure out what's happening at each of these. So we can see that we have a 3 for the minus 3, so that tells us that it's going to be a terrace point. At minus 1, we know that it's going to be a max or a min, so I can put that in. I'm not sure which one it's going to be there. So if we start on the left, we're like, oh, we have to go through this terrace point. Remember to graph a terrace point. We're going to make kind of a quadratic shape in one direction and a quadratic shape in the other direction. And notice that I'm below the graph here. I'm below the x-axis here. So what I need to do then is I'm going to have to turn around quick and then make a maximum, and then I'm just going to go down. I don't need to connect with my arrow that I originally drew, so I can delete that now. So then let's just double check this at negative 3. So at negative 3, we have a terrace point because we have an odd exponent. At the even exponent at negative 1. So we can check those, and then we can move on to the next problem. Again, make sure to pause, rewatch if you need to. All right, so graphing this next one, we'll do the same thing. We want to figure out what is A. A is, that's right, positive. And then what does positive A tell us? As the graph gets larger, the graph is going to go up or down. You're right, the graph is going to go up. So I'm going to draw an arrow going up. And then we want to look at what is n? What is the degree of the function? And how do we do that? That's right, we count the exponents. We have a 5 and a 1. So that means that n is 6. An even function, is it both arrows are going to be going up? Or is it that it's going to be one side up, one side down? You're right, an even function means that both sides go up. So we know that it's even. That tells us both sides are going up. So if I have it going up on the right side, that means the left side is also going to be going up. All right, so at x minus 4, it says that we're just going to cross the x-axis. So for our 0 of x minus 4, that tells us that it's going to be at positive 4, so let's put a point there. A degree of 1 tells us that it's going to be going straight through, exponent of 1. And then at x minus 1, or I'm sorry, at x plus 1, when the 0 is at negative 1, we're going to have, so it's odd greater than 5, so odd greater than 5 tells me it's going to be another, that's right, terrace point. We have a terrace point there. So we can see that our graph, if we start on the left-hand side, we're going to have a terrace point there, so we're going to have to go make a terrace point here. And then we see that we're going straight through, so we have to come down and turn around, and then go back up and through. Notice that I don't necessarily need those original arrows, so I can just go back and erase those, and I'll erase this other one here. There we go. All right, so then if we just double check this, our n is 6, we have a terrace point at negative 1, so negative 1 we have a terrace point at, so that was at x plus 1, negative 1 terrace point. At x minus 4, we have at positive 4, we have a 0. So those are two examples of graphing. If you want to start looking, if you want to do the homework part right now, you can go do those graphing ones now, and then come back and watch the video. The homework problems will be at the end of the video as well, so I'll just keep moving on here. So write the equation of the graph. Remember, the first thing we're going to do is determine the number and zeros of the function. So if n equals 5, that tells me that I have 5 zeros, and I'm looking for my zeros where? That's right, I'm looking for my zeros on the x-axis. So on the x-axis, we can see that we have a 0 at positive 1 and at negative 3. If I write in those factors at positive 1, we know that we're going to have one real 0 because it just crosses the x-axis. And then it looks like I have a max or a min at this point here at negative 3. So that means I'm going to have one real. And then I have what kind of multiplicity? That's right, it's even multiplicity. And if what's 1 plus what even number equals 5? Because remember, we want it to equal 5. So 1 plus an even number has to equal 5. That has to be 4. So my multiplicity is going to be 4. Remember, the multiplicity is my exponents. So when I start to write this, what do I have to start with first? That's right, you have to start with f of x equals a. We're not sure what the a value is. And then let's write those factors. We can see if it's at negative 3, it's going to be x minus a negative 3, or x plus 3 is a factor. At positive 1, it's going to be x minus 1, so that'll just be x minus 1. So let's write those factors. We have x plus 3, x minus 1. And then what is my exponent for x plus 3? That's right, it's going to be the multiplicity of 4. And at x minus 1, my multiplicity is 1. So now, what do we do next? How do we find the a value? That's right, we will look at the y-intercept. So our y-intercept we can see is at negative 3. So if I write the point, it's 0, negative 3. What am I plugging in for x? You're right, I'm plugging in 0. What am I plugging in for y? That's right, negative 3. And y is really going to be our f of x. So y, remember, equals f of x. So f of x is going to be negative 3. We're solving for the a value. We're putting a 0 in for x. So it's going to be 0 plus 3 is 3 to the 4th power. Might have to use a calculator for that. And then now we have x minus 1, so it would be 0 minus 1, or negative 1, raised to the 1 power. All right, and then let's use our calculators to calculate this out. 3 to the 4th power, that would be 3 times 3 is 9, 9 times 3 is 27, 27 times 3 That's the limit of what I would do. So then I would just get my calculator out. All right, so I got my calculator out. And then what I can do is I can just type in 3 to the 4th power. And then multiply with -1. Oops, double negative there. Sometimes that happens. And we get -81. So that makes sense. 3 squared is 9. 3 squared is 9. That would be the same as 3 to the 4th. 9 times 9 is 81 times -1. So then we'll have -3 equals a times -81. Divide that to both sides. So I'm going to divide a -81 to both sides. So a equals, negative over a negative. Those will change to positive. And then 3 divided by 81. That's right, it'll be 1 over 27, we know. So a equals 27. So I need to make sure to rewrite the function. So f of x equals 1 over 27 x plus 3. Make sure to pay attention to my exponents to the 4th power, and then just x minus 1. Remember, you can write a 1 there if you want. You can write a 1 if you want, or you can just leave it there. And then make sure to circle our answer. Remember, we like to double check things. Our degree is odd. 4 plus 1 is 5. That means it's opposite. So I'm seeing that it's going to be opposite here. These are opposite. And then notice that a is positive. So positive means that as x gets larger, it goes up. And as a gets larger, it goes up. Great. So let's look at the next one. And I'm doing a couple of each of these just so that we get more comfortable with that. If you need to come back and look at these, please do so. All right, so write the equation in the graph, n equals 6. So this graph looks kind of symmetrical on first looking. Also notice that a is going to be positive. Our graph is going up as it goes to the right. We already know the degree is even, so they're both in the same direction. So first thing I want to do is determine the number and multiplicity of zeros. It looks like I have a terrace point at -1 and also at +2. So what does that tell me? That tells me it's going to be 1 real 0 and 1 real 0 here. And what does a terrace point have for multiplicity? Is it even or odd? That's right, it's odd. So what two odd numbers, 3 or greater, equal 6? So we need an odd plus an odd equal to 6. And that's right, we'd have to have a 3. So they both would be a multiplicity of 3. That means these exponents are going to be 3. So let's write our function. What do we start with? Yep, we start with f of x equals, we have some a value, and then our factors. Let's go back and see what those factors are. So x minus a -1 will be x plus 1. X minus 2 will just be x minus 2. So x plus 1, made a mistake. Give myself some space. Okay, so x plus 1 to the 3rd power, x minus 2 to the 3rd power. So then what do we do once we are trying to find the a value? That's right, we want to plug in this -2 for our y-intercept. So -2 is going in for the f of x, 0 is going in for x. So -2 equals a 0 plus 1 cubed, 0 minus 2 cubed. So we have -2 equals, this 0 plus 1 will be 1 cubed. 1 cubed will just be 1, so it's really just going to be a 1 there. -2 cubed, 0 minus 2 is -2. -2 cubed is -2 times -2 is +4. +4 times -2 is going to be -8. -8 times 1 is still -8, so we'll just divide this side by -8. Divide the other side by -8, and we can get our a value. -2 divided by -8 will be 1 over 4. Remember, a had to be positive, so I'm just double checking my positive a. And then I just need to plug that back in, so f of x equals 1/4 x plus 1 cubed. Double check your exponents. X minus 2 cubed. Again, check your exponents. So this will be my final answer for writing the equation. Again, make sure to re-watch if there's something that you missed. You can always email me. I'll be checking email on the hour. All right, so we got one more problem. Like I said, we're going to be doing 5 problems. Determine the number and type of zeros. I think this is something where we're struggling most, and that's finding the unreal zeros. So let's find the real zeros first. Where do we look for the real zeros? That's right, we look for them on the x-axis. So we can see that we have a real zero at this point. Remember, we're not paying attention to where what the value is of these, just where they are. So we can see that we have 3 zeros on the x-axis. Next, what we want to do is we want to figure out the multiplicity. So we see some crossings through on the far right. This will be 1 real zero. On the far left, crossing through 1 real zero. And then we have something that's going to have multiplicity. I notice that I have a terrace point. I have to have odd multiplicity. I'm not sure what that odd number is yet. But it's going to be 1 real zero, 1 real zero. So that's 2 plus an odd number. So I have 1 plus 1 plus odd number plus. Then we have to have something else equal to 7. So notice that it looks like we have some unreal zeros. So when we look at this, if you follow the cursor here, is the unreal zero at this maximum, this minimum, or is it this minimum? So remember, what we can do is we can draw some parabolas here, and if it crosses through, then we know that the unreal zeros aren't there. So if I just draw through here, it's like, oh, it went through the x-axis, so no real zeros there. This next one, no real zeros there. Let's do this minimum now. Oh, doesn't cross the x-axis. Looks like that's where my unreal zeros are. And then we can check this other one. No unreal zeros there. So what that means then is that at this point, this minimum above, and remember it's opposite. Minimum above sounds opposite. And we have 2 unreal zeros. So what odd number plus 2, 1, and 1, so what odd number plus 4 equals 7? That's right, 3. So my multiplicity has to be 3. So if I list these out, I had 1 real zero, I had 2 unreal zeros, I had 1 real, multiplicity 3, and I had 1 real zero. Great, nice work. So that was the problems we're going to be working on today. Next, what I'm going to do is I'm going to show you our answer key for practice 5. So this is something that you did for today. So here's 5 and 6. There's the graphs. And then I'll move it down for the rest of it. Remember, you can always go back and pause. I'll do this as quick as possible. And then here's 7, 8, 9, and 10. Notice on number 9, a minimum above the x-axis is 2 unreal zeros. And then also notice that a terrace point off the x-axis gives us 2 unreal zeros. Real zeros are on the x-axis. There's straight crossings. So that gives me 2 unreal zeros. Just double check those. And then, again, if you need to pause or go back, it's fine. And then here is the homework assignment. So this is numbers 3 and 4. Again, if you have any sort of paper at home that you can write these on, try your best. Work through the problems. I have PDFs. If you have a printer, you could print those out, attached to this lesson as well. And then here is 5 and 6. Again, if you need to pause it. If you don't have graph paper, just do your best in graphing. It really just matters where it is on the x-axis. So as long as you can make that x-axis, make some hash marks across, you'll be fine. And then here's 7 and 8, some of the same. So graph the function. Again, pause it so that you can write those down. Whoops. Trying to go down here. All right, so the 9 and 10. Again, we're looking for real zeros on the x-axis, unreal zeros are off the x-axis, and they always come in pairs. All right, and then you guessed it, we still have a ticket out. Ooh, a ding for something. Ticket out, rate your confidence. How confident are you in determining the number and type of zeros? How confident are you in writing polynomial equations from a graph? So that's writing equations. And then how confident are you in graphing equations? You can see the homework at the bottom there. In questions 3 through 10, so practice 6, questions 3 through 10. You either have that or it's what I just showed you. So either way works for me, whether you write it on your original one or you just write it on any sort of paper and hand it in. It's due by 7:59 a.m. in the next class. The reason why I'm doing it this way is so that I have some time to look through your homework in the morning, and then I also have time to make the next video so that I can respond to your questions, I can respond to the feedback from the homework. I hope all you are safe and well, and that it was really boring actually with nobody in here, just talking to myself. So I guess we'll all kind of be in that position for a while. But again, any questions, I'll be checking my email on the hour between 8 and 9. I'm sorry, 8 and 4. Have a great day.